So hello data points. Today we are discussing about 145 ml model, how 145 ml model was architect and how they suffer from a problem. This is the predict the wrong data and find a solution and understand the how the home page are designed and also understand what are the ml model and what are the stack they are using. So let's get started. So first of all, they have the raw data. After that, they inject into the pipeline. This is the high level architecture for just for understanding. And then they train the data on the wrong data, means the data is not actual. Then they model store the model, and in the offline training, after that they are solving and predicting this home interface. Okay, so this is overall page. So let's understood how to make a prediction with the wrong data. So why, first of all, why we need to predict the wrong data? Because sometimes we don't have the enough data to predict, and sometimes the data with the actual data and the solving time data is the different. Means while we are training this data, and when the user, I think this is, I want to play, but ML model suggest I play this. So this is at goes on a top. So this is the actual scenario. At a starting type, each company don't have the enough data to predict on the what user wants. So what happen on the training pipeline reads the raw data, perform the feature transformation and train the model and save the model to the model storage. Okay, understood. Then through the online serving, a recommendation service run in a different infrastructure. If you notice, recommendation system run in a different infrastructure, transfer features, then gives the prediction. Means this is one model and this is another model. This model work on this side and this model work on this side. This is the overall architecture on the Spotify side. What are the problem arise when the feature transformer in the online serving is implemented differently? Means this model is working on different mode and this is working on the different mode. So this is the issues. So input data is different during the training and serving. We already know that input data is not always the output data. So the implementation is just a few lines of code, but it is impact model recommendation serverly. The issues happen for a 4 month before it can detect. So it takes the 4 months to detect this few lines of code. What is the happens? Why this model gives this? Why not suggest this? Like all of this problem. So what are the solutions we found out? So we found few solutions. There are the two main solutions. First of all, one transformation for the both training and solving. So we understood that during the deployment time, we both model are present or solving the one model. Means we train only one model, then we solve from that model. We train one model, then that model solving the another model, like that. Then use the feature logging. Spotify decide to use the feature logging method, just like we are logging our model training all of time using the ML flow or other libraries. We also need to logging our features, then implement the features in the Java, then log already transform the features at the serving stage. This important because offstring service used for feature transformation is owned by the different team. It simply say that one team 1 handle another model and team 2 handle another model. We cannot uh, implement in two model on the one and two both are different. So what we need it, we merge it. We simply merge it. It is difficult to handle all of things. Simply we can uh, handle all of this into a one team. After that they use the TFDV to implement all of this. then set off the alert detect the feature drift. So the what is the ML drift in the deployment? ML. So if you think in the ML deployment, this data set is skewed. A data set is skewed like that. If the our prediction is this black guy, but when in the actual time the model is set, so that is called the prediction. This is called the drift. So this to handle, we need to set a alert for this. If the model is more skewed, then we need to think about our model, and again we can get our, again we need to train this model, again we need to train this model. So let's understood what are the design pages are present on the ML side. So on the ML side we have the good, we have this is called one what this is, few cards are present, and this is the shelf, and inside the shelf we have the few cards. These are card, few are machine predict and few are manually created through by the creator. After that we understood how this is the small model which is predict, and this is which are the bigger model which are forecast model. And what are the ML stack they are using for the data fetching. Then they understood doing the feature transformation. After that the training with the TensorFlow and the Python for the experimental, and for the deployment all of this Qflow. And the deployment side they started with the Spotify or this platform own platform. After that for the solving this all of this prediction they use this model, and for the monitoring end to end TFDK, tensor for data validation, or the dashboard like the Power BI dashboard. So this is the overall scenario, how the Spotify suffer from one model which is the 4 month take to modify, 4 month take to modify. And after that what are the solutions we found? First of all, merge the team and implement the data shift and the logging for the alert, and after that we can predict all of these things. So yeah, this is from my side guys. And how is this visualization? I learned from one YouTube channel. I saw they are also using few icons images on here, so that I also implement. I with the time we are improving. So I think this is helpful. I found these articles on this. I gives the reference of this article. And yeah, so thank you, Johan.